Hello, everyone. Our new lesson is on arcs and chords. So we are going to learn some things about arcs and chords to help us find the measure of them. Okay, without further ado, let's get rocking. So there's a lot of information we're going to go over in this little bit here. So let's just break it down. This first bullet says two chords are congruent if and only if their corresponding arcs are congruent. So what does that mean? Let's look at our picture here. So they're saying AB, this is a chord, and CD are congruent. They're the same measure or length if and only if their arcs are the same. So in a problem, if I was told that AB, let's say, was 30 and CD is 30, then we would automatically know that those chords AB and CD are the same. Okay? So if their arcs are congruent, then the chords are congruent. Okay, that's that first bullet. Another way, that's not going to work. We'll leave it there. Okay. Another way to know if two chords are congruent is if they are equidistant from the center. So AB is equal to CD. So chord AB is congruent to CD if and only if they are the same distance away from the center. So let's pretend if this was 5 and EG was 5, then we would automatically know that those chords in green would be equal. And then, folks, these little arrows means it can go either way. So if we knew that the chords were equal, then we would know the other part would be true as well. So again, key takeaways here, folks, is if we have congruent arcs, then those chords are equal, or if they are the same distance away from the center, your chords are equal. And our last bullet point here, dun, 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 dun. Hold on a second for me. Okay. If a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. So we have some big words here. Perpendicular means, you guys, what? They form a right angle. Bisects means to cut in half. So when this happens, when I have a radius or a diameter that's perpendicular to a chord, it cuts it in half, right? So that would mean AF is the same as FB. So if this was 3, this would be 3. Or vice versa with its arc. Again, we have a right angle here, meaning it's going to cut this arc in half. So DI is the same as CI. So let's pretend, I don't know, 20 and 20. Does that make sense? So then in symbols, they're telling us EH is perpendicular to segment AB. Therefore, AF is congruent to FB, and arc AH is congruent to HB. Yeah, there's a lot of info here, so we're just going to do a bunch of examples to help hit this home, okay? The concepts aren't very hard, it's just kind of remembering what means what. All right, find the value of X. So let's just look at our picture here. I have chord SR and chord ST. And they're telling me they are congruent, right? That's what those tick marks mean. So since I know my chords are congruent, that means their corresponding arcs are congruent. So now I know that arc RS is congruent to arc ST. So now this is a really easy problem to solve. We set them equal to each other. It's just a linear equation. We do this all the time. Subtract over your 24, get 91, divide by our 7, and we get 13. So again, not like it was super hard, it's just remembering if you have congruent chords, you have congruent arcs. Now can we go the other way? This time, they're telling us arc JK is congruent to arc LM. Since we know that, we then know that their corresponding chords are congruent. So pretty similar problem to the last one. We can set 18x minus 2 equal to 52. And then we'll get into just another linear equation. Add our 2 over. Then we divide out. And we should get 3. Okay, next example, in circle G, the measure of arc DEF, so the measure of this big arc here is 150, and we are looking for the measure of arc DE. So we're looking for this. Even if you couldn't remember the property, like you guys are pretty smart people, right? Like just be logical. It looks like it's about half of the whole red arc, correct? So if you forgot that if you have a perpendicular, so if your radius is perpendicular to its corresponding chord, it splits it in half, right? That's our property that we talked about earlier. So if you forgot that, be reasonable. It looks like it's being cut in half, and you're right, it really is. So 150 divided by 2 is 75. 75, 75. Next example, in circle P, EF is equal to GH, which is equal to 24. Find PQ. Okay, this picture looks a lot scarier than it really is. So let's talk about this first piece of given information. They're telling us that EF is congruent to GH. So these guys are congruent, and they're 24. So now we know some things about congruent chords. We know that their arcs are congruent, and we also know that they're equidistant from the center. So now we know that these two little red segments are the same because those chords are the exact same distance away from the center. And our goal is to find PQ. This is what we're looking for. Well, now we have a pretty easy problem because now I know that these two things are equal to each other. So 4x minus 3 is equal to 2x plus 3. Bring your variables to the one side, your numbers to the other. X equals 3. So now that we know that x equals 3, we can plug in to find PQ. So PQ, 4, plug in your x. 12 minus 3 should give us 9. There we go, 9. And then our last example for notes today, in circle P, JK equals 10, and the measure of arc JLK is 134. Find the measure of arc JL and PQ. Okay, let's break this down. Let's talk about this first part here. JK equals 10. So I know this whole length is 10, but since it's perpendicular to a radius, we know we can split it in half, so I'm just going to write that instead. You know, that half is 5, and this half is 5. Perfect. Then we're told that arc JLK, so this big guy, is 134. And our goal is to find JL right here, and PQ. Those are the two things we're looking for. Let's take care of JL. That's the easier thing, okay? So remember, since we have this nice little, our radius is perpendicular to our chord, it cuts everything in half. So in order to find JL, you just simply take 134 and divide it by 2. and we get 67. So that was pretty easy. That one wasn't too tough. Okay, so we just found, I'm going to clean this up a bit right here. This is 67. Okay, but now our job is to find PQ. So we're looking for this. We know that this is 5. Huh. Now I'm kind of stumped because we don't really have anything else to help us find out what X is. But just remember, I'm never going to lead you astray. I'm always going to at least give you a problem that at least figure outable. You might not know it right away, but there's a way to figure it out. I'm never going to give you a problem that is impossible. Even though sometimes it might feel like that. It is impossible, but this one is not. Do you guys notice how they're telling us our radius is 6? And now remember, in a circle, you can draw a radius anywhere. You can draw a radius from here to here to here. So draw in a place that's helpful for you. So I'm going to draw this radius. So I create a nice little right triangle. Do you guys see that? See how we have a nice little right triangle here? You can draw it out right here if this helps you out. This is 5, this is 6, and here's what we're looking for. And now you have your favorite theorem that you've used all stinking year. Pythagoras. So x squared plus 5 squared equals 6 squared. And now we just crunch out our numbers. Take the square root. We should get x is about 3.3. There we go. And that's that. Okay, good job. Proud of you. You did awesome. Until next time, adios amigos.